So we're going to do pressure. So pressure is the force that's acting on a surface. Okay, so we've got the force, which is caused by the weight of the box. Okay, and that's the gravity pulling it down. And then that is exerted on the area of the box underneath here. Now, if you have my shoes, which I'll just show you here, my shoes, you can see at the bottom of my shoe, all the force of my body is going down through my shoes, okay? So we need force and we need the area of which the force is acting on, whether it be there or the bottom of my shoe. So the force divided by the area. So this has to be in newtons, so force has to be in newtons. So you can convert kilonewtons to newtons by just timesing by 1,000. Like I say, kilonewtons to newtons is times by 1,000. We'll talk about the units in the next in a slide or two. So newtons divided by meters cubed. So newtons divided by meters cubed. So that means we're going to talk about an example next where you convert centimeters cubed into meters cubed. So the actual equation is P equals FA. Now you can rearrange that, and I'd try and rearrange it if I was you and put it in the different ways in which, so F equals and A equals. Okay, so try and rearrange it so, for example, they might ask you for the force or for the area and give you the other two. Now we're going to go through one example next, okay, on how to use this. But before we do that, we're going to look at the unit. The unit is Pascal, so pressure is Pascal. You might get a mark for the unit, so remember it. Okay, so let's go to the question. Somebody's wearing a stiletto heel. It's got a force going over 500 newtons going through the heel. Contacts the ground, and the area of the bottom is 1 centimetres cubed. What is the pressure exerted by the stiletto heel on the ground? So first of all, we have to convert the area into square metres. So 1 centimetres cubed is equal to 1 times 10 to the minus 4 metres. Or, if you avoid standard form, that's 1 centimetres cubed, squared equals 0.000, let's start again, 0.0001. Okay? Use the formula P equals FA, so that's the force, and that's the area, okay, because it was 1 centimetres cubed here, so 1 centimetres cubed equals 1 times 10 to the minus 4 metres. Put it in, and you get a force of 5 million pascals. That's a lot of force. That's why basically when you walk on soft ground, it's not good wearing stilettos. You're better off wearing wide shoes, or if you're in the snow, wear snowshoes because of the big area. Now, large pressures are measured in kilopascals. So kilopascals is 1,000 pascals, as we said before, okay, and it can even go up to megapascals as well, okay. And as you can see, these examples, this example here, a different type of stilettos as well here, you see 20 kilopascals, so 20,000 pascals, 500 kilopascals here, and then you've got 5 million here on this one here. So if that's the case, okay, and we look at this here, we can see that there's a very small area. And then basically the smaller the area, the higher the pressure, okay? Again, depends on the force. If the force is very high and you've got a very small area, you've got a huge pressure going through that point. Now the pressure caused by atmosphere is called the atmospheric pressure. And at sea level, that is 100,000 pascals or 100 kilopascals, as you can see here. Now, let's have a look of 1 metres squared, and let's put some cars on it. Okay. And we put a lot of cars there. So, the next bit is, this is equivalent to the weight of 10 cars acting on every single metre. So that's the pressure of this stuff just around us is the equivalent of 10 cars acting on every square metre. So why aren't we crushed? You would be crushed by 10 cars. Now that's because what's inside of us is pushing out. So what's inside of us is pushing out at an equal and opposite pressure. So if the pressure that's exerted on 1 square metre is that which we've said, 100 kilopascals, that must mean we're pushing out at 100 kilopascals. And we are, which is why we don't get crushed. Okay, now let's look at that in a slightly different example. The can, and you may have seen this in a collapsing can experiment in your lessons. The can is not crushed because there is an equal and opposite pressure. Okay, so basically the pressure on the inside is equaling the pressure on the outside, and so nothing's getting crushed. So what you can do is you can suck the air out using a vacuum. So if I suck the air out, there's nothing pushing out. The air's not pushing out anymore, and hence the the pressure from the outside is higher than the pressure on the inside, and the can crushes. So the important thing for your question is comparing the pressure on the inside and the outside of something. So if you see something is not being crushed, that must mean there's an equal pressure on the inside to the outside. If it is being crushed, there's a lower pressure on the inside and a higher pressure on the outside. And the opposite can happen as well. If something blows up, that means there's a bigger pressure on the inside than there is on the outside.